Welcome to our exploration of the fascinating world of aerodynamics, the science that explains how planes stay in the air. Aerodynamics is the branch of physics that deals with the motion of air and the forces it exerts on objects moving through it. It is the fundamental principle behind the design and operation of aircraft, making it one of the most critical aspects of aviation. From the earliest attempts at flight to the sophisticated aircraft of today, aerodynamics has been at the forefront of aviation's evolution. At the heart of aerodynamics are four fundamental forces that govern the flight of an aircraft: lift, weight, thrust, and drag. These forces are in constant interaction, and their balance determines the aircraft's behavior in the sky. Lift is the upward force that counteracts the weight of the aircraft and keeps it in the air. It is generated by the difference in air pressure between the upper and lower surfaces of the wings. This pressure difference is often explained by Bernoulli's principle, which states that as the speed of a fluid, in this case air, increases, its pressure decreases. The curved shape of an airplane wing, known as an airfoil, is designed to create a faster airflow over the top surface, resulting in lower pressure and upward lift. To delve deeper into the mechanics of flight, let's consider the role of airfoils in greater detail. An airfoil is a specially shaped surface designed to maximize lift while minimizing drag. The cross-sectional shape of an airfoil is critical. It is typically asymmetric, with a more curved upper surface and a flatter lower surface. This design ensures that air travels faster over the top of the wing, creating a pressure differential that lifts the aircraft. The angle of attack, or the angle at which the airfoil meets the oncoming air, also plays a vital role in generating lift. If the angle is too steep, it can lead to a stall, where the airflow separates from the wing and lift is dramatically reduced. Pilots must carefully manage the angle of attack to maintain control and efficiency during flight. Weight is the force due to gravity acting on the mass of the airplane. It pulls the aircraft downward and must be balanced by lift for the plane to stay airborne. The distribution of weight within the aircraft is crucial for stable flight. Pilots and engineers must carefully calculate and balance the weight to ensure the aircraft remains controllable. Thrust is the forward force that propels the aircraft through the air. It is produced by engines, which can be of various types, such as propellers or jet engines. Propeller engines generate thrust by pushing air backward, while jet engines create thrust by expelling exhaust gases at high speed. The amount of thrust required depends on the aircraft's weight, speed, and the amount of drag it experiences. Drag is the aerodynamic resistance that opposes the aircraft's motion through the air. It is caused by air friction and pressure differences and can be divided into several types: form drag, skin friction drag, and induced drag. Aerodynamic designs, such as streamlined shapes and smooth surfaces, are employed to minimize drag and improve efficiency. Additionally, the concept of ground effect is worth mentioning. Ground effect occurs when an aircraft is close to the ground, typically during takeoff and landing. The proximity to the ground interferes with the wingtip vortices, reducing induced drag and increasing lift. This phenomenon allows aircraft to become more efficient and requires less thrust to maintain lift, but it also demands precise control from pilots to avoid accidents. Aircraft are equipped with control surfaces that allow pilots to maneuver the plane. The primary control surfaces are ailerons, elevators, and rudders. Ailerons are located on the trailing edge of the wings and are used to control roll, or the rotation of the aircraft around its longitudinal axis. Elevators, situated on the tail's horizontal stabilizer, control pitch, which is the up and down movement of the aircraft's nose. Rudders, on the vertical tail fin, control yaw, the side-to-side movement of the nose. Basic flight maneuvers include taking off, climbing, descending, turning, and landing. Pilots use a combination of control surfaces and engine power adjustments to execute these maneuvers. For example, during takeoff, pilots increase thrust to accelerate the aircraft and use elevators to lift the nose, transitioning from ground to air. Stability in aircraft refers to the tendency of the plane to return to its original attitude after being disturbed. There are two types of stability: static stability, which is the initial tendency to return to equilibrium, and dynamic stability, which is the behavior over time as the aircraft returns to its original state. Aircraft design, including the placement of control surfaces and the shape of the fuselage, plays a crucial role in ensuring stability and smooth control during flight. Modern aviation benefits from advanced technologies that enhance aerodynamic efficiency. Winglets, for example, are vertical extensions at the tip of an aircraft's wings that reduce induced drag. Blown flaps use engine exhaust to increase lift during takeoff and landing, while boundary layer control techniques manage the airflow around the wings to reduce drag. Computational tools and simulation techniques have also revolutionized aircraft design, allowing engineers to test and refine aerodynamic performance before building physical prototypes. In summary, the intricate dance of aerodynamic forces and design elements is what allows planes to conquer the skies. From the curvature of airfoils to the management of thrust and drag, every aspect of an aircraft's design is meticulously crafted to ensure safe and efficient flight. As we continue to push the boundaries of aviation, the principles of aerodynamics remain the foundation upon which all advancements are built, promising a future where the sky is no longer the limit. Thank you for joining us on this journey through the fascinating world of aerodynamics. We hope you've gained a deeper appreciation for the science that makes flight possible. Whether you're an aviation enthusiast, a student, or simply curious about how planes stay in the air, we invite you to explore the endless possibilities that aerodynamics offers. Stay tuned for more insights into the wonders of aviation and beyond. Thank you for watching. If you're hungry for more knowledge, hit that like button and don't forget to subscribe. Your support is incredibly valuable to us.